Graphical method is an easier way to solve linear programming problems. An even easier method we have just discussed was slope method. But these two methods are restricted to only two variables. So here comes the next optimization method, simplex. The simplex method can be utilized to optimize problems having two or more than two variables. Simplex method is a step-by-step procedure in which we improve solution in every step. This step-by-step improvement of solution is known as iterative process. It's a bit lengthier process than graphical method, but solution is more optimized. It follows the same initial procedure as in case of graphical method of finding out objective function and writing constraints. But instead of making graphs, we make tables. The steps involved in simplex method are eradicating inequalities, finding the basic feasible solution, making tables, and iteration. We are going to understand the first two steps in this lecture and the last two with the help of a numerical in the next lecture. So the first step is the eradication of inequalities. Eradicating inequalities is very much necessary for solving linear programming problem using simplex method. So first we will eradicate the inequalities in the constant equation. Let's say 3x1 plus 4x2 less than or equal to 12 and 6x1 plus 8x2 less than or equal to 11 are two constants, and z is equal to 2x1 plus 8x2 is the objective function. First, we will eradicate the inequalities. Since lesser than or equals to sign is there, we will add an assumed variable here. So the constant equation now becomes 3x1 plus 4x2 plus s1 is equal to 12 and 6x1 plus 8x2 plus s2 is equal to 11. Here s1 and s2 are known as slack variables and they must be added to equalize. Now, the objective function must also be modified. However, it will not affect the structure of the objective function, but this is general practice. So we will write z is equal to 2x1 plus 8x2 plus 0s1 plus 0s2. So with these three equations, we have four constants x1, x2, s1 and s2. And hence we cannot solve it using the traditional graphical method. Now let's say m is the number of constants and n is the number of variables. So here in this example, m is equal to 2 and n is equal to 4. Now we have to put n minus m is equal to 0. That means 4 minus 2 is equal to 0. That says that two variables should be put 0. This is the only way to solve using simplex method. And by putting any two variables as 0, it's not necessary that only slack variables can be put as 0. We can put any combination of variables as 0. You can put x1 and s1 as 0, x2 and s1 as 0, and so on. The next step is the very crucial step, that is initial basic feasible solution. We have two constants here and four variables. So by putting two variables as 0, we can get an initial value, or to be precise, an initial solution. This solution is what we call a basic feasible solution. So when we put, let's say, x1 and x2 as 0, we get s1 and s2 as 12 and 11. Here, the variable values having 0 as the value are called non-basic variables, and the variables having values more than or greater than 0 are known as basic variables. But it is not necessary that x1 and x2 are always 0. It can be any combination, as we have discussed earlier. The next two steps, namely making tables and iteration, will be discussed in the next lecture with the help of an example.